Okay, today I'm going to uh, talk about homework 4 on OpenMP. So I'm explaining the code for random array smoothing pipeline. Actually, we did this in the homework 1 and update this for OpenMP. In this code also we used large array for this code, and we are using actually the high performance computer from Sim Center of UTC for this purpose. So this program actually does the four things, like the fills a big array with random numbers, computes its standard deviation, smooth the array with 1D, and computes the standard deviation again after smoothing. So and the whole pipeline actually evaluate the parallel performance of the so it's actually the random, then from the random number it's actually calculating standard deviation, then smoothing is and giving the standard deviation, also giving us the elapsed time for this code. So to start this code, we include Studio H, a library, and for memory math-h, for square root, and the time is time.h for seeding the random number. Also the OpenMP API, OpenMP get thread numbers. There is OpenMP get thread numbers. So is the right timer for OpenMP programs. Also the random array actually there is a random array fills the array in parallel. Okay, the random array fills the array in parallel. I wrap the loop in a pragma OpenMP parallel region with default, and so every variable must be explicitly scoped, and that prevents the subtle bugs in this code. And I use the randmax for random numbers in the array local thread, because each thread keeps its own seed variable, and pragma OpenMP4 divides the index range across threads. And there is a code function called double sum. So the sum uses a reduction to add up elements in parallel. Each thread accumulates locally. OpenMP combines them at the end. Also, the function standard deviation, actually we can compute the mean by calling sum, and then a second parallel loop does the variance with another reduction. Finally, we take the square root, that is standard deviation. And there is another function which is void smooth. Actually, it's smoothing uses separate output array, and the edges are copied and interior points in a weighted mix at the centers and neighbors. And finally, in the main section, main function, actually we allocate the two arrays, start a wall clock timer, generate randoms, and compute the standard deviation is smooth, and compute the standard deviation again, stop the timer, and actually print So before smoothing, the standard deviation we will get from this code, and after smoothing also it will shows the elapsed time depends on the thread count. And finally, actually it's default none forces to mark everything shared or private that prevents accidental races, reduction, variances, random or per thread seed, and different arrays. So now I'm going to uh, run this code and show the output for this code. So to run this code, I have to write another code, that is run underscore tests, and I'm going to use that. And this is the result, like for when the thread is 1, the efficiency is 100%, speed up is 1, and the standard deviation before smoothing 2.885111, and after 1.767501, and when it's 2 thread, the speed up is 2.09%, and when the thread number is 4, it speeds up almost 3.62%, and the maximum speed up is 7.78x, and the efficiency is very low. So actually with the number of thread, the efficiency is going to be low. This is the code actually I want to show. So thank you for watching my videos.